Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question, which states that a 440 volts 50 Hz 6-pole star connected induction motor is rated at 75 kilowatts. The equivalent circuit parameters are, this is R1, R2, XM, X1, X2. This is the friction and windage. This is the friction and windage loss, 1.3 kilowatt. This is the miscellaneous loss, 150. This is the core loss, 1.4 kilowatt. For a slip of 0.04, find the line current down to the motor speed. So we are going to find all this. Let's start with the A part. But first, we have to draw the equivalent circuit of this induction motor. Since this is an induction motor, we have to draw the equivalent circuit of this induction motor. So let's draw it. Let me write the equivalent circuit of this induction motor is. So we are going to draw the equivalent circuit of this induction motor. So the equivalent circuit is this. So here is positive, here is negative. Then here the voltage across here is what? Is V1. The current flowing through here is I1. This is also the line current. So I1 is also equal to IL, which is the line current that we have to find in A. Then now, here is what? Here is R1. Here is what? This is JX1. Then here is JX2. Here is R2. Here is JXM. Then here is what? Here is R2. This resistance here is R2 multiplied by this 1 minus S over S. And here is I2. So I1 is here and I2 is here. So from the equation, R1 is what? Is 0.082 ohm. So here is what? 0.082 ohm. X1 is what? 0.19 ohm. Then, okay, this is X1. So from here, X1 is what? X1 is 0.19 ohm, which is here. Then X2 is what? X1 is 0.19 ohm. Then X2 is what? X2 is 0.18. Then R2 is what? 0.07. Then XM is what? XM is what? XM is 7.2. This is 7.2. Then here we have our slip is what? Is 0.04. So 1 minus 0.04 over 0.04 is 24. So 24. So 24 multiplied by what? R2 is what? Is 0.07. This is 1.68. So here is 1.68 ohms. So now we have labeled all the parameters in this circuit. So now, in order to find this line current IL, we have to find the total impedance of this circuit. That is the equivalent impedance of this circuit. So to find the equivalent impedance, this is A, we are now going to find the line current. To find the equivalent impedance, we have to redraw this circuit. It now becomes what? This is V1. This is what? This is I1. This I1 is the line current. Then this is R1. Then this is the R1. This is JX1. JXF. So let JXF be the equivalent reactance and let RF be the equivalent resistance. So RF is the equivalent resistance and XF is the equivalent reactance of this junction, of this branch. You know, when the current flows and enters this node, it will split. Here, this branch is parallel to this branch. This impedance is parallel to this impedance. You know, equivalent resistance plus J equivalent reactance gives us impedance. So that means this reactance also impedance, this resistance plus reactance is impedance. So impedance, that means this impedance is parallel to this impedance. So this XF is the equivalent reactance and RF is the equivalent resistance of this branch. And you know, the procedure for finding the equivalent impedance in parallel is the same procedure as that of finding equivalent resistance in parallel and also inductance in parallel. So, and also inductance in parallel. So, we'll use that same formula here. Hence, we can conclude that 1 over ZF, ZF is the equivalent impedance now. 1 over this branch is parallel to this, so this 1 over this JXM plus 1 over what? Let me call the total impedance here Z2. So we can conclude that ZF is equal to 1 over what? 1 over JXM plus 1 over Z2. So now we can substitute these parameters here. We have that ZF is equal to 1 over JXM is this. That's J7.2 plus Z2 is what? Z2 is here. So, and these all are in series. So, and this is resistance, this is resistance. So 1.8, and this is resistance, this is resistance. So 1.68 plus 0.07 is what? This is 1.75. One over 1.75. This is the resistance. Then plus J 0.18. So this makes impedance. So this is resistance plus J reactance. This makes impedance. We can plug this in the calculator directly. But first, But first you have to put the calculator in compress mode. So it will be 1 over, this is what, 7.2, then j is same thing as I, then plus 1 over what, 1.75 plus 0.18 I. So this is what, 1.577 1.577 plus 0. To 3 decimal places what, 550. Then there's I here, or j, which is j and I are the same thing, the same root of -1. So this is 1 point, so this is what, 0.550 j, that is to 3 decimal place, then 1.577. And you know this is the rectangular form of this impedance. If you want to convert it to polar form, you can convert it using this. You press shift. When you press shift, then you press this. You can see this is an option for polar and this is an option for rectangular. So you press shift and this, you see this option will come out. Then you put the first one. Make sure you put it from the first one to the second one. You put the resistance, which is the first one. Then you press shift and this comma here. You get this comma, so you can see the comma. Then 0.55. You see, so this we have converted it to what, to polar form. Now you can see this is equal to what, 1.67. then angle, here is the angle, 19.2 degrees. Then you can press boom. So these are the answers. This is the rectangular form and this is the polar form. So now we have to find the phase voltage before we can find the line current. Now the phase voltage is given by this, the voltage 440 over root 3. That's the phase voltage. So this is 254. This is the phase voltage. Then now we can now find the line current. So the line current, which is equal to I1, is equals to, so the line current which is equal to I1, this I1, if you analyze this circuit now, you see that all these impedance are in series and there's a voltage V1 and there's a current I1. So if you use normal Ohm's law here, which is V is equals to IR, you use normal Ohm's law here, you can see that the current I1 here will be nothing but the voltage V1 divided by the total or the equivalent impedance. So this becomes what? V1 which is the voltage, divided by R1 plus JX1 plus RF plus JXF. So now, and we have found RF and JXF from here. You know, as I said before, I said this ZF is the equivalent impedance of this branch from here. Now, and we found it. So now this one is our RF and this one is our XF. And we have R1 and JX1 already here, and we have found the equivalent here. So now we just substitute them. This becomes what? V1 is what? Is 254 over R1 is what? 0.082 plus J, what is X1? Is 0.19 plus RF is what? Now RF is what? 1.557. 1.577. So this is the rectangular form of this answer. Let's write it down before we convert it to the polar form. This is what? 127.697 minus minus 56.959. Let's just leave it like this. Let's not approximate it. So it will be minus 56.959. Let's leave it like this. This is J. So now shift, then 127.697, then shift to press the comma, then negative 56.959, then close bracket. This is 139.82, which is approximately 140. So this is equal to 140, then angle of negative 24.0 degrees. So this is, and we can say is ampere, so in ampere. So this is the final answer for this. So this is the line current. We have solved the A part. Let's move to the B part. So the B part says we should find the stator power factor. So to find the stator power factor, the formula we're going to use is this. The power factor is equal to what? Cos theta. But the angle cos theta, and the angle we're going to use is what? Is this angle of the line current, which is 24. So we're going to use 24 degrees. We'll remove the negative. But even though we put the negative, we'll still get the same answer. So cos 24.0 degrees, which is what? Cos 24.0 degrees, which is 0.914. Even though you put the negative, you still get the answer. So it's 914, 0.914, 0.914, and it's lagging. The power factor of both the stator and the rotor of an induction motor are always lagging. So before we find the power factor of the rotor, we have to find the impedance angle of the rotor. So the impedance angle of rotor is given by this, which is equal to what? Tan inverse x2 over r2 over s. So this becomes what? Tan inverse, what is x2? x2 is 0.18. What is r2? 0.07. 0.07 over the slip, which is s, is what? Is 0.04. 0.04, 0.18, 0.1028. So tan inverse 0.1028, then tan inverse 0.1028. So this is what? This is 5.87 degrees. So now we can approximate it. So now the rotor power factor now is given by this. This is the rotor power factor. This is cos. This is the angle we are going to use. 5.87. This is 0.995. Lagging. So this is the power factor of the stator, and this is the power factor of the rotor, and which are both lagging because it's an induction motor. So next is to find D, the stator copper losses, which is PSCL. So the stator copper loss. So the stator copper loss is given by this formula: 3 IL square R1. This IL is the line current. 3 IL square R1. So which is equal to 3 times what is the line current? This is 140. We will not put the angle here, only the magnitude, which is 140. Times R1. What is R1? 0.082. This is 3 times 140 square times 0.082. This is 48 21. This is approximately 4822, and it's watts in watts because a loss. So the next one is to find the air gap power. And the air gap power is given by this formula: 3 IL square, then RF. Slight change from this. Now, what is RF? This is RF. RF is this 1.577. This is RF. From this ZF is equal to RF JXF. So this is 3 times 140 square times 1.577. This is 92727. If we express this answer in kilowatts, it is what? If we express this answer in kilowatts, it is 92.7 kilowatts. Then the power converted from electrical to mechanical form, that is P converted, and the formula is expressed as 1 minus S, then times the air gap power. This is equal to 1. The slip is what? 0.04. Then what is the air gap power? Is what? Is 92.7 kilowatts. So 92.7 times 1 minus 0.04. This is 88.99 kilowatts. And if we express it in one decimal place, it is 89. So this is what? This is 89.0 kilowatts. Then the next one, G, is the induced torque. The induced torque. The induced torque is given by the air gap power over Ws. So now we have to find Ws in order to find this induced torque. Ws is the synchronous speed in radian per second. So first we have to find the synchronous speed in RPM before we find the synchronous speed in radian per second. So synchronous speed in RPM is 120 F over number of pole. This 120 times 50, which is the frequency. Frequency is given 50, and the number of pole is 6. 120 times 50 over 6 is 1000 RPM. So this is the synchronous speed in RPM. So now to find the synchronous speed in rad per second is 2 pi ns over 60. So this is 2 times 3.142 times 1000 over 60. So this is the synchronous speed in rad per second, 104.7 rad per second. So now we can find this. What is the air gap power? The air gap power is 92.7 kilowatt. And since this is in kilowatt and our induced torque must be in Newton meter, we have to multiply the 1000 over 104.7. 92.7 times 1000 over 104.7. This is 885.4, but we can write it as 885 Newton meter. So this is the induced torque. Then the next one, H, is the road torque. The formula for the road torque is given by the output power over Wm. So to find the output power is equal to what? The converted power minus the friction and windage losses minus the core losses minus the miscellaneous losses which are here. So the converted power is what? Is 89 minus this 89 kilowatts minus friction and windage loss is 1.3 kilowatt. The core losses is 1.4 kilowatt, and the miscellaneous losses is 150 watts. But all the other units are in kilowatt, so we have to divide this one by 1000 to convert to kilowatt. So this is what? 150 divided by 1000 is 0.150. So 89 minus 1.3 minus 1.4 minus 0.15. This is 86.15. This is 86.15. This is 86.15 kilowatts. Then we have to find this, the speed of the motor. So first, before we find this, we have to find the speed in RPM, which is given by this formula, 1 minus 0.04. The synchronous speed is what? Is 1000. This 1 minus 0.04 times 1000. This is 960 RPM. Then we can directly substitute this here. This becomes, the output power is what? Is 86.15. Then times 1000 over, this is 2 pi ns over 60. So it is 2 times 3.142 times 960, like we did here, over 60, like we did here. So this formula here is the same thing like we did here, but the difference is that this one is m. So this one will be, and this one is m, this one is m. So this one now turns to mwm is equal to 2 pi nm over 60. So that is why we're going to use 960 here as our nm instead of ns. So it's the same thing. So it's the same formula. So the subscript that changes. So this becomes what? 86.15 times 1000 over 2 times 3.142 times 960 over 60. This is 856.8. So this is equal to 85 what? 857 Newton meter. So I, the overall machine efficiency. So the efficiency of this machine is given by what? The output power over the input power times 100%. And what is the formula for input power? We have already calculated the output power. We need to calculate the input power. So what's the formula? The formula is given by 3 V1 I1 cos theta. And you know I1 is the line current. So this is 3 times what is V1? V1 is 254. Then what is I1? I1 is the line current, which is what? Is 140. We are using the magnitude, not the angle. Here, 140. Then what is the angle? Cos. The angle we are going to use now is 24, which is the angle of this current. We are going to use the angle of the line current, which is cos 24.0. Here we are only going to put the magnitude. We are not going to put 140 angle of negative 24. But here is cos theta. We are going to use the angle. So now we are going to put this in the calculator. 3 times 254 times 140 times cos 24. This is 97457. 97457. And the output power here, the output power is 86.15 times 1000 over 97457 times 100 times 100%. This is equal to 88.4% approximately. This is 88.4%. So the overall machine efficiency is 88.4%. So now J, the motor speed in revolutions per minute and radians per second. So the motor speed in revolutions per minute is given by 1 minus s times the synchronous speed, which is 1 minus 0.04. The synchronous speed is what? Is 1000 rpm. This 1 minus 0.04 times 1000. This is 960 rpm. This is the motor speed in revolutions per minute. Then to find the motor speed in radian per second is, we use the formula Wm is equals to 2 pi nm over 60, which is 2 times 3.142 times 960, which is this. So times 960 over 60. So this becomes what? 2 times 3.142 times 960 over 60. This is 100.5 approximately. That is rad per second. So these are all the solutions of the question asked. That is A to J. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel and hit the notification bell to get notified as soon as I drop a new video. Thanks.